One change I am doing to the fixed bias circuit, I am adding an additional emitter resistance. Usually in common emitter amplifier, the emitter side will be grounded, right? I am just doing some modification to the circuit to see whether my stability factor is reducing or not. So one slight change what I do from the previous circuit is I am adding an emitter resistance RE for improving the stability factor. Improving means it is not increasing, for reducing my stability factor. Because the lower the stability factor, the circuit is going to be more and more effective in tackling the variations in temperature. So this biasing circuit is called as emitter feedback bias. When you study these type of circuits, you have to relate and study what is the difference in this circuit compared to the previous circuit. So in previous circuit, there was no RE. In this circuit, I am having extra RE. So putting this extra emitter resistance, it is going to do a big deal to my circuit. Yes, it is going to improve the stability factor of your circuit. So I am not doing anything different. I am just adding one emitter resistance. And the purpose of adding emitter resistance is justified by the fact that it is going to improve the stability factor of my circuit. See, we have three stability factors, S, S dash, and S double dash, right? For all these circuits, you'll be finding only S. We will not do S dash and S double dash because it is going to be zero. The variation is very, very minimal. Only for the last circuit, we are going to find all the three. Okay, so don't think that we are finding only one stability factor and concluding the stability factor is poor. So for other two stability factors cannot be found here because circuit is very, very basic. Or I can say the variation in S dash and S double dash is going to be zero. Okay, so same way for analyzing the circuit, what you should do, apply KVL at the base side. So base side means this loop. Okay, remember always base side means this is the loop you have to visualize and apply the KVL. For applying the KVL at the collector side, this loop. Okay, so two loops are there. Input side means at the base side I have to apply KVL. Output side means at the collector side I have to apply the Kirchhoff's voltage law. Because why I am applying KVL here? Because I want to design the values for RB, RC, and RE. Because they decide the operating point of my